wherever you are, and welcome to this morning session on getting started with AWS DeepRacer. My name is Ricardo, and I'm going to be your co-pilot today for the first session. So over the next 40 minutes, we're going to help you get started with DeepRacer, get you started in creating your first reinforcement learning model. And then afterwards, after a short gap, I'm delighted to be joined by my co-host Lyndon Leggett, who is going to be helping me cover some of the more advanced topics. So without further ado, I'm going to start straight away with, first of all, a kind of overview and introduction in what reinforcement learning is, and then I'm going to cover actually getting you started with doing your first DeepRacer model. So before we do that, it's always good to understand and know a little bit more about reinforcement learning so that it can help us when we come to start creating our models for our cars, how we can make them perform better. Okay, so if we look at machine learning as an area, okay, we perhaps been more used to working with supervised and unsupervised learning. Okay, so perhaps you've got lots of data, you've got lots of labeled data, and by labeled, what we mean is you've got ground truth. So you've got perhaps some pictures, and the pictures have been identified as this is a cat, and this is a dog. And then you can use that data set with some algorithms such as classification algorithms to then determine based on a new picture whether this is a cat or a dog. Okay, but maybe perhaps you've also got other types of data where you don't have any ground truth. Okay, but you've got a gut feeling, okay, that you think that there's different groups of documents. So this is where we typically use algorithms that sit under unsupervised learning. And you can use that then perhaps to create categories of documents. So this is perhaps a medical document, this is a legal document, that kind of thing. So as you can see, this is all around how much data you've got and whether you've got some ground truth around that data. And we can then start to pull this into a kind of graph with the amount of data that you have to build a model versus the sophistication of the model that you will create. So as an example, if we want to create a supervised learning model that identifies objects, we need a lot of data. Okay, we need a lot of data that is labeled, and that will provide us a good degree of sophistication in that we can put an image into that model, and then it will tell us what that picture is. Consequently, also we might also have a much smaller amount of data, but we could do the job ourselves. Okay, we could categorize a group of documents into different categories, so the level of sophistication perhaps is less. So where reinforcement learning fits into this, okay, is where perhaps we have no data or very little data, but we want to have a high degree of sophistication in modeling. So if you look at the real world in how this works, so those of you who've got children or who've got pets and you've tried to train those pets, okay, you typically start off with trying to create effectively a reward mechanism to incentivize the behavior you want. So in this instance, I have a dog and I want to make sure that the dog is behaving well. So I reward the good behavior and I don't reward the negative behavior. And as a result of that, I hope to get an outcome of a well-behaved dog or child. And when we try and put this in the context of other examples, so for example, many of you, and I'm going to borrow an example from one of my colleagues, Julien, when you were small and you were trying to learn to ride a bicycle, you would have started with the bicycle, you would have understood that you can sit on the bicycle, your parents would have encouraged you with good reward, say, well done, you've learned to cycle. The negative reward would have been falling off and hurting yourself. And what you would learn over time is as you start pedaling and you start understanding how to balance, that when you pedal more, it helps with balance and it helps you stay up, you fall less. Result is that you actually get from A to B. So you're able to use the positive reward of my parents giving me encouragement, my parents helping me to learn and take me to a safe place to learn to cycle, the negative behavior of falling less over time and being able to get to where I want to as the result. And the satisfaction, I've now got independence. I can now ride a bike and I can ride it faster. And over time, I can now do things like wheelies and things like that. And so when we take that example and try and kind of break it down, we have the concept of an agent, which in the bike example would be yourself as learning to ride the bicycle. And you have a number of actions you can do. So the actions might be pedal faster, pedal slow, brake, steer to the left, steer to the right. And I'm doing that whilst interacting with an environment. So I'm learning to ride my bicycle in a park, perhaps on the street. And as I'm doing that, as I'm interacting with the environment, that environment is changing. And so I'm taking on board what the current environment is. So if I cycle 1 meter forward, then perhaps I'm getting closer to a curve or maybe an obstacle. And so by doing that, then I will then know how I then need to take a subsequent action. Okay, so these are some of the kind of the key concepts that underpin the reinforcement learning. And when we look at real world use cases of reinforcement learning, they tend to be used in very large, complex environments where perhaps there's uncertainty, maybe there's a lot of dynamicism in the environments, and where you require continuous learning. Okay, and so I've listed some of the use cases here, but let's dive deep into a couple of them. And so the first one is recommender systems, okay, where if you think of the agent as the recommender, so how can I make recommendations to the person viewing this that are more relevant to the person? The action will be to choose among any number of items that recommender system is recommending. The state that we're trying to get to is the fact that the person looking at this is interested, and the ultimate reward is a transaction, customer satisfaction, they've chosen the right thing. So you can see that this is a very complex system, and perhaps we don't start off with lots of data. And so reinforcement learning is a good candidate for this use case. And then we've got energy systems. So if you imagine a complex environment of having to maintain kind of a nice temperature for a building, there's lots of variables that make that complex and changing environment. The number of people in the building, the size of the building, maybe the season we're in, all those kind of things. And so what we're trying to do is maintain a comfort for those people. So the agent in this instance is going to be the control systems that manage all the HVAC systems. The actions they can take are things like turning on and off heat systems, changing control. And then the state is really what temperature and pressure a particular room or floor is currently at. And ultimately we're leading to the fact that we've got comfort for the occupants. And then the final one, which probably is most common, is the fact that it's very useful for robotics. So if the agent is a robotic arm that has got specific motions it can do, that a camera or other sensor is used to determine what the current state is, we reward it when it's completed a specific task. So it might be that a gripper to move an object from A to B might be the task we're creating. Okay, so that's a very, very quick overview on reinforcement learning. And what you'll see as we now dive into DeepRacer is that one of the kind of the keys to success is really understanding some of those concepts. And so what you'll hopefully learn to do is as you start getting more experience, some of those themes you will start diving deep in, you'll start researching yourself, and that will help you get better models and faster times. We do have chat. I'm happy to say I've got some moderators on the chat. So any questions you've got, please use the Twitch chat. I will be looking at this from time to time, seeing if there's anything that you want me to answer. And I will then kind of come back and mention that in the actual stream itself. So if we look now at why we created DeepRacer, one of the things that we do at Amazon is we're customer focused, and we realized that after introducing reinforcement learning to SageMaker in 2018, what we wanted to do is figure out how we could help more developers learn and understand this form of machine learning. And so with that, and based on the success we had previous year with Deep Lens, we came up with the concept of DeepRacer. And so what DeepRacer is, is a car which I have next to me, and when we, I'm not sure if we can see that on the yes we can. I can see that now. So we have a car which is like a remote control car, which has got a Intel based computer on there, a camera, and we use that in our physical races. But on top of that, we also have a virtual simulator on which we train and evaluate a model before putting that onto the car. And then on top of that, we have global racing leagues. And the racing leagues are both physical, so we had Toronto recently, but over the last several months at the summits, if any of you have been, you would have seen the DeepRacer circuits there, and people would have been taking part in the workshops to create a winning lap for the circuit, for the summit circuits. But on top of that, we've also had monthly virtual circuits, and we currently have one running until the end of October. And the winner of both the summit circuits and the virtual circuits win a trip to reInvent in December. And also you win a car. Now, I'm delighted to say that as part of this session, we have our own private league that we'll be running. So people who are watching this, I encourage you all, after you've listened to this session and the next session that follows, to start working on your model, submit to the league, and then you'll also have a chance to win some of the prizes, which I'm going to talk about a bit later. Okay, so I've got a question about how to share some more examples of how reinforcement learning can be used. Okay, so what I'll do is I'll leave some of the moderators to tackle that as I go through. If I have time at the end, I'll try and go into more detail than some of the examples I've already talked about. So I mentioned some of the terms on reinforcement learning. So I now want to try and bring them into what those terms mean in DeepRacer. So we have this concept of the agent. Okay, so in the example I gave, it was me riding a bicycle or learning to ride a bicycle. In this instance, it's the car, and so the car is what we will deploy the model onto, and the car can do a number of actions. Okay, so in this car, it can turn left, it can turn right, it can go straight ahead, or it can accelerate at certain speeds. It can go backwards as well, but hopefully we don't want to do that when we're racing. And we operate that agent with those actions in an environment. Okay, so this is where we have the racetrack. And for the purposes of this session, we're going to be using the standard reInvent racetrack. But as we've introduced new summits and new virtual races every month, we've also introduced new racetracks. Okay, so as you get more advanced, you'll start to interact with new environments. When we're doing that, when we're taking our agent to take an action in an environment, we need to make sure that we're rewarding the right behavior. Okay, so we need to create a reward function, and we're going to dive into that in a bit. And the state is, once we've taken an action in that environment, okay, it generates a new state. Okay, and so that new state will be a result of the action we've taken and a reward, and it will help us then plan how we then will optimize the next action to take. And finally, we have the concept of an episode. So when the car is learning, initially, it has no understanding of how to interact with the environment. So it'll tend to look like it's operating in a very random way. Okay, and so an episode is all the actions it takes before the car comes off the track. Okay, and so we will collect the state, collect the data every time it does from the start of the episode to either when it completes a lap or when it comes off the track, and then the car gets reset and we begin again. So these are going to be some of the key concepts that we cover. Okay, and so when we look at actually how learning kind of takes place, the agent will take an action in that environment, and that action in that environment will generate a reward, and that reward will then allow the agent to then understand what the new state is, and then take a subsequent action. And what happens, this happens lots of times. The car has a camera on board which is working at 15 frames per second, which means every time it takes a picture, so one of those frames is one of these actions, okay? And it creates this tuple of data, the action, the state, the reward, and then the next state. And these are used over time to help the model, the reinforcement learning model, understand, based on where I currently am in this environment, what is the best action to take. So this is the policy function. So if I see the track ahead of me in my camera and it's going to the left, the action I think I need to take is steer left, or vice versa. If I see a straight ahead, then don't steer and go straight. Okay. Now that in itself is okay, but what we also need is we need to make sure that we incentivize with the reward the best option. So we might have more than one outcome we can do, more than one action. And so the value function there is used to incentivize the action with the highest cumulative reward. So one of the interesting things about addressing this particular challenge, so using reinforcement learning for getting a race car to go around the track, is that if we compare it to the old way of doing it, which is what we call behavioral cloning, which is where you as an individual would take the car, drive it around a track, and during that process you would be collecting images through the camera. You would then use that through a labeled data set, i.e. This was a good lap, we'll use that as ground truth. This was a bad lap, we won't use that as ground truth. You can use supervised learning to create a model that will help that car go around the track. One of the, I guess, disadvantages of doing that is that the model you create will only ever be as good as the person that taught it. Okay, whereas with reinforcement learning, because the virtual agent is exploring the entire environment, you may end up getting a much more optimized and better a model that can perform faster than a human equivalent. And we've talked about the reward function already, and I guess this is really important from the point of view of making sure that you think of the reward function of incentivizing the right behavior based on what you want it to do. Now, when we start off with the base track, the reinvent track, which is what we'll be learning on, the reward function is going to be pretty straightforward. As we go forward with newer tracks, we may need to pay more attention to the reward function. And one of the things we'll be doing and talking about in the later session, the advanced section, okay, is understanding how to understand whether the reward function is doing well or not. And one of the things I also like to talk about is the reward function is really, really important to think about from the point of view of the intention you have versus the incentives you give. Now, this is a picture of one of my colleagues, an eastern brown snake, and I use it to illustrate the Cobra effect. The Cobra effect was a good example of perhaps the wrong incentive being given with the right intention. So back in, I think it was in India, the regional governors wanted to reduce the number of deadly snakes, cobras, I believe. And so they provided a Cobra bounty. The idea was that if you killed a deadly snake and handed it in, you'd get a bounty. And in the short term, this was very successful, and they saw a drop in the number of deadly snakes and a drop in the number of people who died from snake attacks. But then over time, what they realized actually is that people would actually be bringing in lots of snakes, and what people were doing was actually breeding snakes and handing them in for bounty. And so what they realized is when they did this, they stopped the actual program, and then all these snakes that had been breeding were then let out in the wild, and suddenly they had a much worse problem than they started with. So you need to be careful when you're creating your reward function and think about the intention that you want, i.e. I want this car to go round the lap the fastest, or I want this car to go round this particular corner in a certain way, and then the corresponding incentive that you have in your reward function to do that. And again, you'll use the log analysis tools that we'll talk about in the next session to understand how your reward function is doing what you think it's doing. And so now if we try and kind of break this down into kind of like sort of more, just looking at the Twitch channel for any questions. So yes, the presentation is going to be up on demand afterwards. And okay, cool. Right, so if we now kind of like break down into a much more simplified model how the training works. Okay, so we've got our agent here, and the goal is to finish a lap. Okay, and so we think of the reward function as a grid. Okay, so we know that we want to incentivize. In this instance, okay, the fastest way to get to the goal is the straight line. Okay, we know that if we go off the track, we will reset the episode. We want to disincentivize that, so we get no points. But somewhere in between, there's going to be different rewards based on turning left and turning right. It's not that you won't finish the goal, i.e. you won't cross the line, but it's not going to be in the fastest time. And an episode from the animation, you can see, happens as the car is exploring. It will explore the environment, and once it goes off the track, it will end the episode. And depending on how well the car's done, that might be straight away, or it might be after 20, 30, 40 steps, depending on how well the model is working. And this happens over time, okay? And what's happening, okay, at this point is the car is exploring the environment. Now, during this process, the data that's collected will be collected every now and then and used to train the model. So that what you'll notice when you're doing this is that the car will appear to pause every now and then. That pause is because the SageMaker is being used to train the model. The model will be redeployed on the car, and then the car will start again. And this time it should, in theory, be better because now it's got an updated model. It knows how to interact with the environment better. So it's exploiting the information it's got whilst it's still exploring to see if it can optimize and get higher cumulative reward. And so this is what it actually looks like. So on the left-hand side, when you start, your car, very much like my driving normally, looks a little bit like that. And then over time, you know, and as you get older and more experienced, your driving looks more like on the right-hand side. And this is important because over time, what you want to make sure is you don't get stuck in a rut, because it's very easy that you might end up getting into a situation where the reward you get looks like it's the best, but actually without a combination of both exploitation and exploration, you won't end up in the optimum path, which you can see on the screen there. Okay, right. So what we're going to do now is we're going to kind of switch from theory and now talk a little bit about the actual virtual simulator. And walk you through kind of the overall steps. Okay. Now, under the covers, okay, DeepRacer, this is the kind of the collection of services that we're using to create the model, to train it in the virtual environment, and to create the model we end up with, which you can deploy in the car or in the virtual race. So we're using SageMaker and RoboMaker. The RoboMaker provides the virtual environment. SageMaker is used to train the model. And there's backwards and forwards between those as we are training and collecting data in the virtual environment. We're optimizing that in SageMaker, redeploying it back into the virtual environment over the duration of the training. And then we use the corresponding services, S3, Kinesis Video Streams, and CloudWatch to make sure that we capture the data, store the model, and also make really, really important that we get all the log data and metrics so that we can help improve over time. When we actually start this process, okay, what will happen is the first thing we do is we create the model. And I'm going to go walk you through this in a minute, but there's three things that you will do as a person creating your first DeepRacer model, okay? The first one is to create the model in the console. And there are three things you do. You create the reward function, you can modify the action space, and then you can tune the hyperparameters. So what do these things mean? Okay, so I've already talked about the reward function, okay, which is a piece of Python code that is used to encourage your car to behave the way you want it to behave in the virtual simulator to achieve the total maximum cumulative reward over time. The action space, we've already covered this as well, is defining the actual actions the car can take. So the left steer, the right steer, the acceleration. And then the hyperparameters are the tuning knobs that we have for the actual training of the machine learning itself. So those are the things as a person you can influence when you're doing and configuring the training. When you then actually train, you train for a duration of time, after which, when you've completed the training, you will have a model, and depending on how you feel about the model, you can then evaluate. And what the evaluation does is it actually puts into the evaluator and will tell you how well that model does around the track. Now, within the DeepRacer console, you've got the option, if you want to automatically submit that to the virtual DeepRacer League, or just test it locally if it's the first time you've done it and you don't want to, maybe try that, again. And then, based on how you've done on number 4, if you've got a pretty poor time or you think you can go faster, what you then do is you can then tweak the model, okay, and then you can then clone it and then retrain. Now, at this point, it's important to know that you can change the reward function and you can change the hyperparameters, but you can't change the action space, okay? So you can iterate for just those two things and increase that over time. If you feel that you're not getting better by changing the reward function or hyperparameters, at that point you would create a new model, and then that would allow you then to create a new action space. So let's look into what these actually look like now, with the action space being the first one. So the screenshot here is a little bit out of date. I think they changed the maximum speed, I think, in the last couple of weeks. I think the maximum speed now is, 10 or 12. So the first one is the steering angle, and this is really what maps to the physical car. So I mentioned RoboMaker. We have a virtual representation of the DeepRacer car using RoboMaker, and that car has been modelled as accurately as it can be with the physics of this car. So the steering angle and the steering granularity are what the car can actually do, but they're also what we can model in the RoboMaker environment. The maximum speed here you can think of more as throttle. So it's actually how fast the throttle is. And then we've got the constant of granularity, okay? So we can change these, and what will happen is if we increase either the granularity or the maximum speed, then what that gives us is a much larger action space. We can reduce these and have a much smaller action space. So we could, in theory, for example, have just 3 steering angle granularities and have maximum speed of 1. And that would give us probably the smallest action space. But it might not be very efficient at getting around some of the tracks, and it might not be very good at getting a good time. Okay, so you have to think about your action space at the beginning based on what you're trying to achieve. Then we come to the reward function itself. Now, within the console, you've got an area where you can actually put your reward function. We provide 3 sample ones, which are basic, but they're good enough for you to get started. And importantly, there's a validate function which will allow you to make sure that the function works. You can't actually submit a reward function that doesn't work, so you need to click on the validate function before you submit. So don't worry, you can experiment, you can try things, click on the validate, and if it doesn't work, go back to scratch, or go back to one of the examples to get you going again. Okay. And then one of the kind of the next important thing when we're looking at the reward function is some of the information we make available to you to help you with the reward function. Okay, so we pass some data from the virtual environment that allows you to build the necessary incentives to make your model do what you want it to do. Okay, so we've got some concepts here around the track boundary, the track, what the field is, and these are important from the point of view of understanding what they mean in the context of the parameters we provide when you're creating your reward function. So these are the current ones, and each of these has got a detailed breakdown in the documentation. And what these allow you to do is, within your reward function, is to take this and help influence the reward you provide. So, as an example, one of the example ones is distance from the middle of the track. And it uses that variable to understand in the virtual simulator how far is the virtual car away from the center of the track. And based on that, you can then choose to incentivize that with high reward and disincentivize it with less reward based on it being further away from the center line. It's important to realize that these parameters and the reward function itself is only relevant in the virtual simulator. Okay, what we're doing here is we're creating the mechanisms to create a model. Okay, the model of which will then be deployed on either the virtual circuit or the real car. At which point it's just a model. Okay, and it's not using any of these things. So these things are only used when you're training. And just to kind of try and kind of bring to life a little bit about how some of these look, we can see that we've got car direction, the track width, all these kind of parameters we can see, and this is what it looks like when it's actually in action. There's a nice little animation here that shows, in this instance, the heading and how it changes as the car is going around the track. This one is for waypoints. So for starting from 1 all the way around to 30, you can use potentially the waypoints to perhaps help you understand where you want to brake and accelerate. And then whether all the wheels are on the track or not. Maybe you want to kind of like race hard on the racing line, which means that sometimes your wheels are going to come off the track. And then the one I've already mentioned, which is how far you are from the center line. I'm not going to cover these in too much detail in this session. We'll cover these later, but these are the parameters that you get to control, to choose when you're training your model. And like I said, we're going to cover these in more detail in the next session. Which now I'm happy to say I'm going to go off the actual off the presentation, and we're going to go straight into creating our first model. So let me just check to make sure there's any burning questions. Okay, so there's some great questions. So keep the questions coming, guys. So as the cameras change, you can see this is what the car looks like, and this is the physical car, which if you've been to a summit, you will have seen, and winners of those in the virtuals will actually get. So let's go to the console. Okay, so when you a couple of things first of all. Number one is the DeepRacer is currently only available in the North Virginia region, so make sure that you're in the North Virginia region. Otherwise, you won't see this. You'll actually get a redirect to this. The easiest way to find it is just type DeepRacer from the console, and you'll see it there. Okay. So when you first get into this, you'll see this screen. It's great because it gives you a link to all the resources over here on the right hand side, related services being used, and really important, the pricing information. So how much this is going to cost you to use. So we provide a free tier for this, and we pretty much allow you to have about 10 hours worth of training. Okay, but please make sure that you are looking at your AWS bill as you're doing this to make sure that that you're within the boundaries, and keep an eye on that. And then there's some additional learning resources here. Okay, so to actually get started, we'll go to the main screen here, and it's as simple as, first of all, creating your model. Okay, now the first time you do this, I've already done it. Okay, you'll have an orange box here, which says create resources. Okay, and what this is going to be doing, is going to, under the covers, it's going to be creating all the additional resources that DeepRacer needs in order to function. Okay, if you have recently done this, then great. If you did this a long time ago and then left DeepRacer and have come back to it recently, what I would urge you to do is reset your resources. There's been some changes recently with the architecture of DeepRacer, which will mean that you need to reset the resources to make sure that you're not using some of the services that are no longer used by DeepRacer. So if it's been a while since you've been on DeepRacer console, but you've already done the create resources, please make sure you do the reset resource to get the optimum experience. The first thing we then do is create a model name. So let's first model. So we create a name, and then we jump straight into the track we want to train on. Okay. Now I would encourage most people to start with the reInvent track first. I know it's tempting to go on some of these other tracks because they look really cool, and they are really cool. But start on here because a lot of the resources that we're going to talk about later on, a lot of the community expertise and experience is based on this track. And so as a starting point, it's going to be your best way to learn some of the techniques, which allow you then to kind of move on to some of the other tracks. Okay, so now we're into the action space. Okay, so this is where we get to choose what in the virtual simulator our car is able to do. And you can see that I've got different granularities I can choose. I can go from 0 to 12, and I've got different granularity for speed as well. Okay, and if I change this, what you'll notice at the bottom here, okay, is that I have an action space, and I've got 14 there at the moment. But if I wind this all the way down, okay, so now I'm literally, this is probably how I normally drive: hard left, straight, hard right, and then one speed. That's the action space now. Okay, a much smaller action space. Now, the ramifications of this, okay, for training is that the bigger the action space, the longer it's going to take for your model to train. Okay, but consequently also, the less sophisticated your model is going to be, and probably the less optimized your model will be at getting the fastest time. So if your objective is to win a race and to get the fastest time, I suspect that having this action space is probably not going to be optimal, but maybe someone out there can prove me wrong. And once we've done that, we then get to the reward function. So this is the Python code that you will write. And you can see in this instance, we've grabbed some of those parameters I talked about, okay, assign them to variables. We're using those variables with some calculations, and then we're then assigning a reward and then returning that reward, okay? And we have a number of different examples here: follow center line, stay inside the two borders, and prevent zigzag, which you can see here. All are based on similar core code with some additional areas there, okay? And then we click on validate to make sure it's happy, and we can now look at the hyperparameter section. And here you can see the hyperparameters, which again we're going to talk about in the next session, so I'm not going to go into too much detail. What I will say is that for all of these sections, if I click on info, you can see that we've got help and a description on what each of these are and how they impact the training. And then the last part is the stop condition. So this is how much time we're going to train. Now, you can do it from 5 minutes to up to 8 hours. So I'll leave it for that. I'll click on start training, and that's it. We are now starting our first reinforcement learning training model, okay? And what it's going to be doing under the covers, it's going to be start spinning up all the AWS services it's going to be using. So RoboMaker, SageMaker, and some of the other components. So this might take a few minutes. Now, in good Blue Peter fashion, I did one earlier. So this is the one I did earlier. So this is about, we'll see how, this was about 2.5 hours ago. Okay, so we can see when we first started, what will happen is that the console will generate a graph. Okay, it's a very simple graph, and it will graph two things. It will graph the progress of the car across the objective, which is to finish a lap, versus the amount of reward, the cumulative reward for that episode. And as you can see, and what we're aiming for is a nice steady climb so that we can get to a complete 100% completion of the track with a nice reward on that. Now, as you can see, this is currently paused. And for those of you listening, hopefully, that means that it's currently in the process of training via SageMaker. Once that's finished, it will then deploy that onto the car, and we'll start seeing the car move again. What you'll also notice, okay, is we've got access to the simulation job in RoboMaker. We can access the logs through here, as well as the training jobs in SageMaker as well. Okay, so as you get more curious, and as you start exploring how to optimize and make your cars go faster, you'll use those links to go faster. Okay, so how are we doing for time? Let's have a look. Oops, no, it's not what I want. Okay, right, so Let's go to RoboMaker. Okay, so here's what the actual virtual simulator looks like. You can actually access the RoboMaker environment, and you can see now that this is the one that I did earlier. So it's still very much in the phase of exploring. Okay, it's getting better at doing some of the action. So it knows how to get around that curve, for example, but then it kind of like overcompensates and comes off. So it's using the services here. You see that there's a little bit of drifting there happening. So it's using this, and you can actually monitor if you want, your model as it's training. So, what happens once you've completed your model? Okay, once you've completed your model, so I've got a model here that I've completed. Once your training is finished and it's completed, we then want to do an evaluation. So we click on evaluation. And again, at this point, we can evaluate this on any track. So now we've got our finished model. We can now test this model on any of the tracks. So again, I'm only going to try this one on the Reinvent one because it's a very basic model, and it's probably not going to do very well in some of the more advanced tracks. Okay, and then we can give it a number of trials to do. So we'll select 3 to begin with, click on Start, and it's now going to take that model, submit it to the virtual kind of evaluation process, and it's then going to come back and tell us how well that model did at completing a track. Okay, now it's important because this is the same mechanism that's used when you submit to the virtual leagues. So whilst this is waiting, because it's going to take a few seconds to do that, let's talk about the virtual leagues. Okay, so those of you who've signed up to the Innovator Challenge will have seen this page, okay, which gives you all the resources you need to get started, but also crucially talks about how you get started in our challenge, okay? And really what you're doing, okay, is creating a model in the way I've just shown you, optimizing it in the way that we're going to talk about after this session, and then submitting that to the current virtual leaderboard. And the current virtual leaderboard, I believe, is not that one. It's this one here, I think. So summits, the virtual one. Here we go, view leaderboard. Okay, so this is the current leaderboard. We may see a familiar face here in position 15th. So that's Lyndon, who's going to be joining me a bit later. So what will happen is you will submit to this leaderboard. Don't worry if you don't appear in the top 3 or 4, because what we're going to be doing is we're going to be taking just the people that have registered for this event. We'll be creating our own leaderboard, and once this league finishes, which is at the end of October, we'll process that, and sometime mid-November, we'll then announce the winners of the prizes. And the prizes are, I believe, here we have 3 prizes of AWS credits based on your podium place. Okay, so very well worth doing. So I hope to see many of you doing this. Right, so we've now finished our evaluation, and you can see that for this particular model, I've managed to get 1 lap complete at 13.351 seconds, but 2 laps that didn't quite make it, right? So maybe this is a good model or not, but what you ideally want to aim for, depending on what your objective is to try and get a degree of stability where you've got at least 1 lap or 2 laps where you're going around reliably. Okay, so that's submitting to the. Okay, now once we've got once we've finished the evaluation, we can now go to how you submit your model to the virtual league. And so on the actual DeepRacer console, if we click on the DeepRacer virtual circuit option, the first thing you'll be asked to do is create an alias for yourself. So this is my alias. And then you find the current open virtual league. So it happens to be Toronto at the moment. We see there's 14 days left, which is until the end of October. So you've got 14 days, folks, to do this. You can then use the submit model option, and you then select the model that you've got from the ones you've created already. It's as simple as clicking on that, and it will okay, so I've exceeded one of the limits at the moment, so that's why it's not letting me do that. So I can't show you this at the second, but it's as simple as submitting the model, and then it will automatically do the same process. It will evaluate. It will then tell you whether you've been successful, whether you've got a lap that was successful, and then it'll give you a position in the leaderboard. Now, it allows you only to do submit one model every 30 minutes. So you are able to submit as many models as you want. Right, let's see if there's any questions on this, because I'm sure there's a few. Okay, right, okay, it looks like some of the folks are answering, which is great. So let's go back to the presentation. So just going to wrap up now before we go to the next session. So I've talked about the DeepRacer challenge for Innovate. So I'm hoping to see lots of you create models, optimize those models through the next session, and then take part in this challenge. I've shown you how to do that. Now it's your turn. Okay. So with that, I think we're at time. Thank you very much for your participation. Don't go anywhere though. In about 5 minutes' time, I'm very happy to be joined by Lyndon, who is he's the founding father of the DeepRacer community here in the UK, but it's actually become a global phenomenon. And he's going to be here to share his tips and tricks to help you create winning machine learning models. So tune in 5 minutes. What I will say before you go though, if you want to join that community, there's a link there on the screen. Go to that link, sign up to the Slack community, where there are hundreds of other people who have got different levels of expertise, experience, both in DeepRacer and reinforcement learning. And as a community, we're all helping each other learn reinforcement learning. We're all helping each other improve our DeepRacer skills and get faster times. Okay, so with that, I'm going to leave you and we'll see you in about 5 minutes' time.